This sample problem is on Newton's laws of motion that involves friction. A man pushes a 15-kilogram box horizontally across the floor as shown below. The box accelerates at 2 meters per second square. If the coefficient of friction between the box and the floor is 0.60, what is the magnitude of the force exerted by the man? So first, let's analyze the free body diagram of the box. So to draw the free body diagram, let's have a dot in the middle of the object, which is the box. The forces acting here would be the force of gravity. We have Fg, or equal to the weight of the box. And that is equal to mg. And there's also normal force because the object is on the floor. And this normal force Fn is actually equal to the weight of the object, or the force of gravity. And we have the applied force that is directed to the right. This is our force applied, or the force exerted by the man. And friction would be pointing in the opposite direction. Now, since there is acceleration, that means to say that the applied force is much greater than the kinetic friction. And this friction, by the way, once again, is kinetic because the object is moving. So the question is, what is the magnitude of the force exerted by the man? So as a matter of fact, we need to solve for this applied force. So we set our Newton's second law of motion. We have F net is equal to ma. Now, since this box is just moving along the x-axis or horizontally, so we will expand F net by looking into the forces along the axis of the motion of the object. So in this case, the horizontal axis. So our applied force would just be, so our net force would just be applied force and friction, or the sum of the applied force and friction. So let's have that. We have F net, the applied force is pointing to the right, so it's going to be positive. We'll have FAPP minus friction, which is directed to the left. So I'm going to have FK, I'm just going to call it FK, which is kinetic friction. And that is equal to MA. Now we expand FK now, so our applied force is what we need to solve for. Kinetic friction is just equal to mu k times the normal force. This is the formula for kinetic friction. Mu k, which is the coefficient of friction, times Fn, which is the normal force, again, that is kinetic friction, is equal to ma. Now we expand this further because we don't have our Fn. So we will have F applied minus mu k. Now our normal force here, this Fn, right? This perpendicular force exerted by the ground on the object is in fact equal to the force of gravity, and we have established this earlier in our free body diagram. So if the force of gravity, or the weight of the object, is equal to mg, then therefore the normal force is also equal to mg. So let's have that then. Normal force is equal to mg. So once again, when the object is on a flat surface, the normal force of the object is just equal to the weight of the object, which is equal to mg. All right, moving on to the equation, and this is equal to ma. Now we're ready to substitute our values. So the applied force is what we need to solve for, minus the coefficient of kinetic friction, which is given to be 0.60. The mass of the object is 15 kilograms, times the acceleration due to gravity, which is 9.8, is equal to the mass again of the object, which is 15 kilograms, times the acceleration of the object, which is 2 meters per second square. And then you could just plug these values in your calculator. So we will have our applied force is equal to 118.2 newtons. So once again, in solving problems like this, the first thing that we need to do is to draw the free body diagram so that we would be able to know what are the forces on the axis that would allow us to be able to expand our F-net. And once again, the F-net or the forces on the F-net would just be the forces along the axis where the object is moving. And our friction is equal to mu times the normal force, or the coefficient of friction times the normal force. And if the object is in a flat surface, the normal force is just equal to the weight of the object, mg.